Hello, and welcome to our study guide review of systems of equations. Now, I wanted to do this a little bit different this time. I wanted to make, instead of trying to make two really big videos, I wanted to make a video per page, so it'll be a little bit shorter per video. See how that works out. That way, you only have to watch what you choose to watch. So, again, I'm going to put my warning in front of every video here, but make sure you've tried the problems before you watch this video, because it doesn't help you to watch me solving the problem unless you've gone through and done it. Alright, that being said, let's get started. Okay, question number 1. We have a system of equations with two lines. Which of the following statements are true, right, yes or no? And it looks like they have a bunch of points. Okay. I think the easiest way to solve this puzzle is to do just a little bit of plugging in. So if I'm going to do A, if I'm saying 0, 2 is a solution to line 2, I'm going to rewrite line 2 here. So we have x plus 5y equals 10. And instead of putting x and y, I'm going to write 0 for my x value and 2 substituted in. I think this is the easiest way to solve this one. So it's going to be 0 plus 5 times 2 equals 10. 5 times 2 is 10, so 0 plus 10 is 10, and this side equals 10. And since that's a balanced statement, I would say yes. 0, 2 is a solution to line 2. Same way. Ooh, this one says negative 5, 3 is a solution to the system. Well, I know we can go through and solve the system. We can do that, or we can just plug it in. But if we plug this point in order for it to be a solution to the system, we're going to have to plug it into both equations. So that's still a possibility. But what I'm going to do is, since there's two questions about if it's a solution to the system, and E says there's no solutions, I'm going to try to solve this system and see how it works. Now, we could solve it with elimination. Actually, you know what? Let's do elimination. And how I'm going to solve this with elimination is I'm going to multiply this bottom equation, everything, by 2. Because then that will give me, equation 1 will say 2x minus 2y, that's a minus, equals 4. And then if I'm going to distribute that 2 to both sides of the equation, I get 2x plus 10y equals 20. And now we have two equations. We're going to smush them down like a sandwich. Negative 2x and positive 2x, that will give us 0x. So in other words, this is a they're eliminated. We eliminated x, which is good. And then we're going to get a negative 2y and positive 10y. That's going to give us an 8y. And 4 plus 20 equals 24. Oh, this is working out nice. Because now we just divide by 8. And we get y is equal to 3. Okay, so it's possible that 5, 3 is a solution because that has 3 as a y. Also means that the answer to C is going to be a no. But now what we need to do is figure out what our x is now. So let me hit pause and clear the screen a little bit just to kind of make some room. Alright, so we got y is equal to 3. And if I want to find what x is, I'm going to plug it into either equation. I'm going to go with the second equation here. So I'm going to say x plus 5 times 3 equals 10. And 5 times 3 is 15, so x plus 15 equals 10. I'm going to subtract 15 from both sides and get x equals negative 5. And I have my ordered pair, negative 5 comma 3. Ooh, that's a yes. I think I erased the s there on accident. And that, of course, means that it does have a solution, so 1 and 2 have no solutions. That would be a no. Alright, almost done. All we need to do is D, which is looking at just line 1. Alright, and I erased the screen. Hopefully there's not any specks left for those that get freaked out by when there's a single speck left. Oh, you know who you are. Oh, yes. I'm calling you out, superstar, because you're one of those people. So negative 10, 8 is the solution to line 1. Let's look at line 1. I'm going to plug in negative 10 for x. Well, that's a negative 2. Negative right here. Minus 2 times y is 8 equals 4. Oh, I couldn't fit it on the screen. Sorry. All right, let's multiply this out. Negative 2 times negative 10 give me a positive 20. 2 times 18 is 16. Does 20 minus 16 equal 4? Yes, it does. 4 does equal 4. So that is a solution to line 1. All right. Okay, number 2. We got we haul and you haul. Now, just because I've seen this problem a little bit, I want to let you know that the scale is going to be weird here. This is a weird solution, so before we do this, we're going to think about something here. So, A, write two equations that represent the situation, and B, we're going to represent them on a graph. Okay, so $20 moving truck, $20. Oops. So $20.45 per mile is we haul, and then U-Haul rents the same size moving truck for $1 per mile with no upfront charge. All right, we can do this. So my equation for we haul is going to be y equals, I'm going to write it in slope-intercept form. I would say 45 cents per mile is my rate of change or slope, so it's going to be 0.45x plus my y-intercept, the one-time fee, is $20. And then U-Haul, try to keep it in y equals mx plus b, would be y equals 1x plus 0. You don't need to write the 0, but I just want to make sure it's clear what is my y-intercept. Okay, so the thing that's weird about this equation is it's the y-intercept for we haul is going to be 20, so we're going to start up at 20, and the y-intercept is for U-Haul is 0, so that's going to give us some space. So I'm going to set the graph, I'm going to try to change my scale on both the x and the y, and I'm going to go up 5 per square. Alright, so let me set that up for a second. Alright, so what you'll see, what I've got set up, I know this is sort of messy, but again, I'm writing on an iPad screen. It's not great. So on the x-intercept we have miles. Each one of these squares goes by 5, and over here we have the cost, and each one of these squares goes up by 5. Now the reason I did that is because if you think about this slope, it's going to be very gradual unless you change the scale here. So for instance, if I'm going to start graphing the we haul, it's got to start at 20. So 5, 10, 15, 20, we'd put a point right about there. Now, if it might make more sense to think about this in terms of how much it would cost for each 10 miles instead of just 1 mile, and what the rise of a run. So if every time I go 10 miles, that's going to charge me $4.50. That's just 0.45 times 10. $4.50 is approximately 1 square, so that would make my slope a little bit easier to graph. So I'm going to go for every 10 on the x-intercept, I'm going to go up just 1 on the y. So it kind of looks like I'm going over 2, up 1 every time. Over 2, up 1. And this is not a great looking model, but you can probably draw a better one on yours. That's we haul. And now with U-Haul, that's easy. Since it's a slope of 1, that means the x and y are going to be equal. So I'm going to start at 0 here, and I'm going to go right through all these points till it looks like they cross somewhere around here. Oops, I missed. But you can see how the graph looks. This should be trying to figure out what that point is. It's somewhere around 36 miles. I think it's 36 point something, where the two companies are going to cost exactly the same, and then afterwards the U-Haul is going to cost more than the We-Haul. Alright? So this is the end of the first page. I'm going to stop the recording now. Why don't you do this? On this page, to prove that you watched this video, why don't we do, let's do this kind of funky guy. Like eyebrows, tongue sticking out. Alright? And then when it's time to check, maybe you can earn some little credit for having that little guy there on page, for page 1. Alright? I'll see you guys back for part 2.